So today we start a new unit, Unit 8, Coordinate Geometry. Okay. Our first page in this unit will be page 111. Equations of lines, midpoint, and distance. So part of today is going to be familiar. Part of it, it's going to be new. Okay, so let's turn to page 111. Our objective is using 2 points, determine their midpoint, distance, slope, and the equation of the line passing through them. So we're going to start with a little bit of review from algebra. So a lot of this should feel pretty familiar since it is mostly algebra review. Okay? The first thing I want you to remember is slope y-intercept form. So what is slope y-intercept form? When we're graphing a line, we typically graph it in the form y equals mx plus b, where b is the y-intercept and m is the slope. Okay. Another form that we can put our line into is called point slope form. And that would be y minus y1 equals m times x minus x1. Okay. M is the slope again, but x1 and y1, notice the little subscripts I'm putting on? They're the point on the line. So they could just give us a slope and a point, and we would be able to figure out the equation of the line from that. Now, I don't like using point slope form personally. I think it's a lot to remember. I always end up using slope y-intercept form, y equals mx plus b. And I can show you how we can get around not ever using this one. Okay. The last thing that I need you to know about lines or 2 points on this topic is the formula for slope. And what slope is it's the change in y over the change in x. So y2 minus y1 for x2 minus x1. And again, these are subscripts, they're not exponents. Where x1 comma y1 is the first point, and x2 comma y2 is the second point. So if I were given 2 points and I wanted to find the equation between those 2 points, this is what I would do. So let's say I'm finding So you want to determine the line between, or that passes through these points. Okay, so I want to determine the line that passes through these points. The first thing I'm going to have to do is figure out the slope. So this is my x1, y1. This is my x2, y2. So my slope my y2 is 10, my y1 is 4, my x2 is 3, my x1 is 1. So my slope, 6 minus 4 is, or 10 minus 4 is 6, 3 minus 1 is 2, 6 divided by 2 is 3. So my slope is 3. Okay. Now, I could use this formula right here and plug into this formula and evaluate. Okay, but this formula is a lot to remember, and I know you all know this one. So I have the slope. I need the y-intercept still. So I'm still going to use this point to find my y-intercept so I can write it in this form. So if I wanted to write it in this form, I'd use y equals mx plus b. Okay, I know my m is 3. My x, I'm going to use the first point. So y is 4, x is 1, and I can solve for b. So 4 equals 3 times 1, which is 3, plus b. B is 1. So the formula of the line is y equals 3x plus 1. If I wanted to use point-slope form, or if they asked me to write it in point-slope form, I'd do the same thing, except that I'd use this formula, and it would give me the same equation of the line. So y minus y1, so y minus 4, equals my slope, which is 3, times x minus 1. So this would be written in point-slope form. I like this better, and if I were to evaluate this, you'd see 3 times x is 3x minus 3 plus 4. If I move the 4 over, I get 3x plus 1. Okay, so if I were to finish evaluating this, I'd get the same as this. But I like this better because I only have to remember one equation. I should know this because sometimes they're going to ask me to put it in point-slope form, but I like this better. Okay. Now, that's one thing we can do with 2 points. We need to do 2 other things. We need to find the midpoint and the distance between the 2 points. So midpoint, I'm just going to take the average of the 2 points. So for midpoint, that formula, I'm going to write it actually as a point. It'll be x1 plus x2 divided by 2, and y1 plus y2 divided by 2. So if I wanted to find the midpoint between these 2 points, I would just do x1 plus x2, divide that by 2, y1 plus y2, and divide that by 2. So my midpoint between those 2 points would just be 4 over 2, comma 14 over 2, or 2, comma 7. Okay, so that's how I'd find the midpoint between 2 points. Last, I want to find the distance between 2 points. Okay, and the distance formula is kind of funny, but I think we can relate it to something we already know. So distance is the square root of x1 minus x2 squared plus y1 minus y2 squared. You're thinking, this is Northrop, this looks like nothing I know. But if I were to square both sides, the radical would cancel and d would become squared. And this still doesn't really look like anything we know. If you already know what I'm talking about, you might be jumping here and being like, ooh, I know exactly what you're talking about. But this might not be anything you that looks familiar to you. So what I'm going to do to help you see exactly what this is I'm going to plot the 2 points that we were working with before. So 1, 4 and 3, 10. And I'm going to show you what this looks like if I were to plot it. 3, 4, 5, or 5, 6, 7, 8, 9, 10. So here's the distance between these 2 points. There's 1, 4, and here's 3, 10. Now one of the ways I could figure out what this length is to use the Pythagorean theorem. Right? If I knew this length and this length, I could figure out this length. Well, I know this length is 2 long. So that's 2. And I know this length is 6. So I could just do 2 squared plus 6 squared equals x squared, because x is my c value, my hypotenuse. And I get 4 plus 36 equals x squared. 40 equals x squared. I need to take the square root. That would be 2 radical 10. Okay? If you're not sure how I simplified 2 radical 10, or how I simplified radical 40, 40 breaks into 4 and 10, 2 and 2, 2 and 5. So the square root of 2 times 2 times 2 times 5, I find my pair. They get to come out as 1. So I'd be left with 2 times 5 inside, so that'd be 2 radical 10. So this length is 2 radical 10. And if I were to use this distance formula, I'd get the same value. So how is this, the Pythagorean theorem, related to the distance formula? Well, let's take a look. Let's use the distance formula and see if we notice any similarities. So I'm going to do d equals the square root of x1, 1, minus x2, 3, squared, plus the square root of y1, 4, minus y2, 10. And I get d equals the square root of negative 2 squared plus negative 6 squared. D equals the square root. 2 squared is 4. 6 squared is 36. I'm seeing some patterns here. Notice this is 4 plus 36, 4 plus 36, 2 squared, 6 squared, and then I have the square root over it. So where did this come in? Well, when I was solving for x, to get x by itself, I had to take the square root of both sides. So I ended up taking the square root of 40, which is what this is. So that's 2 radical 10. I already did the work up there. So the distance formula is really just the Pythagorean theorem solved for c. Okay. The last thing I want to talk about, let's make sure we highlight that distance formula, is how to graph a line. Okay. If I have the equation of a line, this is my x-axis, this is my y-axis. And going back to my equation from the previous page, y equals 3x plus 1. My slope is 3 over 1. My y-intercept, my b value is 1, so that's 0, 1 for my y-intercept. Here's 0, 1. I'd move up 3, right 1. So I started at 1, which was my y-intercept, and I moved up 3 over 1. Y equals 3x plus 1 with a label. That's how I would graph that line. So now we know how to find the midpoint, the distance, the formula, and the slope between two lines, and we are ready for class on Monday. Please, if you have questions about how I did this, make sure you come in ready to ask. Okay? Oh, the other thing I wanted to briefly grab you about is if I use this formula over here, that point slope formula, I can graph a line from this too. I just have to remember that this is my x1 and my y1. So my x1 would have been positive 1 because the formula is x minus x1. So the opposite of negative 1 is positive 1. And my slope is still 3 over 1. So all I would have done here is I would have gone to 1 over 4 and then started my graph by going up 3 over 1. I like y equals mx plus b a lot more, but if you can remember point slope formula, you won't have to solve this to get it into this form to be able to graph it. Your choice. I try to remember, minimize what I have to remember. That's it.